sill level refers to the height at which the bottom edge of a window, known as the window sill, is installed above the finished floor level of a room. It plays an important role in building design, affecting aesthetics, functionality, lighting, ventilation, and safety. Key aspects of sill level. 1. Standard heights. Residential buildings, the sill level is commonly set at 900 mm, about 3 feet, from the finished floor level. Commercial buildings, it may vary, often higher due to desk or workstation heights or lower for larger glass panels and improved daylighting. Bathrooms and utility areas typically have higher sill levels, around 1050 to 1200 mm, for privacy. Bedrooms or living rooms might have lower sill levels, 450 to 600 mm, if the window design allows, especially when full-height windows or French windows are used. 2. Functional importance. Lighting and ventilation. A well-positioned sill allows natural light and air to enter effectively. Furniture planning. The sill level must align with furniture like tables, beds, or countertops to ensure usability and safety. Safety, especially in high-rise buildings, the sill level must be high enough to prevent accidental falls. Building codes often dictate a minimum height for habitable spaces. Privacy and security. Higher sill levels can reduce direct line of sight from outside and offer more privacy. 3. Architectural considerations. Aesthetic alignment. Sill levels should align with other horizontal elements in the building, such as lintels or wall paneling, for visual harmony. Window type dependency. The sill level may change depending on whether the window is fixed, sliding, casement, or designed to be operable for ventilation. 4. Code compliance. Many building regulations and codes specify minimum sill heights for different types of rooms and uses. For example, bedrooms in upper stories may require sill heights of 1067 mm, 42 inches. Or window guards, depending on jurisdiction, for fall protection. Conclusion. The sill level is a crucial architectural and design element that affects not just how a building looks but also how it functions in terms of safety, light, air, and comfort. Proper determination of sill height requires coordination between architects, interior designers, engineers, and compliance with building codes. The standard height of a sill level refers to the vertical distance from the finished floor level, FFL, to the bottom of a window opening in a building. This height is an important architectural and structural parameter, influencing aesthetics, ventilation, safety, and functionality. Standard sill level height. In most residential and commercial buildings, the standard sill height is typically 600 mm to 900 mm, approximately 2 to 3 feet, from the finished floor level. Common standards by building type. Building type typical sill height, from FFL. Residential buildings 600 mm, 750 mm. Commercial buildings 900 mm. Kitchens and utility rooms 900 mm, 1050 mm. Bathrooms, if applicable, often higher or frosted glass. Factors affecting sill height. Purpose of the room. Living rooms may have lower sill heights to enhance views, while kitchens and bathrooms usually have higher sills for privacy and practicality. Safety. In high-rise buildings or children's rooms, higher sill levels, above 900 mm, may be required to prevent falls. Aesthetics and natural light. Lower sill levels allow more daylight and a better outside view. Window type and design. Casement, sliding, or fixed windows may dictate different sill heights. Furniture placement. The sill height may be adjusted to avoid obstruction by furniture like beds or sofas. Building codes. Local building codes or national standards like the National Building Code, NBC, in countries like India, or International Building Code, IBC, in the US, may specify minimum sill heights for certain use cases, especially where safety regulations are concerned. Conclusion. While the 600 mm, 900 mm range is standard, sill height should always be determined based on the function of the room, safety requirements, and local building codes. The sill level in building construction refers to the height at which the window or door sill is placed above the floor level. It plays a significant functional role in architectural design and building safety. Here is a breakdown of its functional importance. 1. Water protection. The primary function of the sill level is to prevent rainwater or surface water from entering the building. By raising the sill above ground or floor level, it acts as a barrier that directs water away from the interior spaces. 2. Structural integrity. The sill level provides a horizontal separation between the base of the wall and window or door openings. It enhances the stability of walls by distributing loads more evenly and allowing for proper integration of lintels and frames. 3. Safety and security. Setting the sill at an appropriate height reduces the risk of accidental falls, especially from windows. It also acts as a minor deterrent to unauthorized access through lower openings. 4. Ventilation and lighting optimization. Proper sill height allows for better control over ventilation and daylight. Higher sills can prevent direct glare while still permitting light to enter, whereas lower sills can enhance visibility and airflow. 5. Thermal and acoustic insulation. Sill levels contribute to insulation by minimizing direct gaps or exposures at floor level. This helps reduce heat loss and blocks external noise to some extent. 6. Aesthetic proportioning. The sill level influences the overall visual harmony of a room or facade. Consistent and appropriate sill heights contribute to balanced window and door placements. 7. Furniture and interior planning. Sill height affects the placement of furniture like desks, beds, or seating near windows. Keeping sills at a standard level ensures compatibility with interior layouts and usability of space. Conclusion. The sill level, though often overlooked, plays a crucial role in ensuring water protection, structural support, safety, comfort, and aesthetics in buildings. Setting it correctly based on function, climate, and design standards is essential in architectural planning. Architectural considerations of sill level. In architecture and building design, the sill level refers to the height at which the bottom of a window opening is placed above the floor level. Though it may seem like a minor detail, the sill level plays a critical role in functionality, aesthetics, structural performance, and safety. Below are key architectural considerations related to sill level. 1. Functionality and usability. Ventilation. A lower sill level can enhance air circulation, especially in tropical or temperate climates. It allows windows to be opened at a height where cooler outside air enters more effectively. View access. The sill level should be low enough to provide a good outside view while seated, yet high enough to ensure privacy where necessary. Furniture placement. In residential interiors, sill height affects where furniture like beds, desks, and sofas can be placed. Higher sills can allow more flexible furniture layouts. 2. Safety and code compliance. Fall protection. In multi-story buildings, local building codes often dictate minimum sill heights, e.g., 900 mm or 36 inches, to prevent accidental falls. Child safety. In homes and schools, higher sill levels help prevent children from climbing and falling out of windows. Emergency egress. For bedrooms or living spaces, sill levels must sometimes allow for egress in emergencies. This typically requires lower sill heights and larger window openings. 3. Aesthetic and proportional balance. Visual harmony. Sill height impacts the appearance and proportion of windows on a facade. In classical architecture, aligning sills with other horizontal elements, like lintels or cornices, creates balance. Interior design cohesion. Internally, sill levels can be aligned with dado rails or other trim elements to maintain visual consistency. 4. Climatic and environmental factors. Rain and dust protection. Higher sill levels can help prevent rainwater splash or dust from entering through open windows. important in tropical or desert climates. Thermal comfort. Proper placement can help regulate internal temperatures, especially if coordinated with shading devices or overhangs. 5. Structural and material considerations. Wall construction. Sill height determines the portion of wall structure required beneath the window, affecting load distribution and material use. Window detailing. The sill itself must be designed to resist water infiltration. Materials like stone, precast concrete, or metal flashing are commonly used to create a drip edge. 6. Typology and building use. Residential versus commercial. Homes often have varied sill levels based on room use, whereas commercial buildings tend to have uniform sill levels for efficiency and design uniformity. Code compliance of sill level in building construction. Sill level refers to the height of the bottom part of a window opening measured from the floor level. It plays a significant role in ensuring occupant safety, comfort, and adherence to local and international building codes. Ensuring code compliance of sill level is critical in both residential and commercial construction projects. 1. Definition and purpose of sill level. The sill level is typically the horizontal member or the bottom edge of a window frame. It is essential for preventing water ingress, providing structural support, ensuring safety against falls, aiding in thermal and acoustic insulation. 2. Minimum sill height requirements. Building codes specify minimum sill heights, especially for habitable rooms and upper floors, to prevent accidental falls. For example, International Building Code, IBC, requires that the bottom of the clear opening of a window, in sleeping rooms, must be no more than 44 inches, 1,118 millimeters, above the floor to allow egress. If a window is more than 72 inches above the ground, the sill height should be a minimum of 24 inches to prevent falls, unless guards or other protective measures are installed. National Building Code of India, NBC 2016, typically recommends a minimum sill height of 900 millimeters, approximate 3 feet, in residential buildings. For schools and childcare facilities, this may be increased for safety. 3. Sill height in different occupancies. Occupancy type. Typical minimum sill level. Residential 900 millimeters, 3 feet. Commercial/offices 750 millimeters, 900 millimeters. Schools/institutions 1000 millimeters, 1100 millimeters. High-rise buildings may require guard rails or increased sill height above a certain floor level. 4. Compliance considerations. To ensure sill level compliance, the following must be considered. Fire safety and egress. In bedrooms, windows often serve as emergency exits. Child safety. Lower sill levels may need guards in areas accessed by children. Accessibility standards, ADA. Windowsills and thresholds should not obstruct access. Local codes. Always follow jurisdiction-specific building codes and amendments. 5. Non-compliance risks. Code violations and penalties. Increased risk of injury. Reduced egress in emergencies. Insurance and liability issues. 6. Best practices. Always refer to the latest version of your local building code. Work with licensed architects or code consultants. Use guard rails, safety glazing, or window restrictors where sill levels pose fall hazards. Document compliance during inspections and audits. Conclusion. Code compliance of sill levels is not just a regulatory requirement but a key factor in building safety and functionality. Proper design and adherence to code help mitigate risks, ensure user safety, and avoid costly corrections post-construction.